Hello, welcome to this video. Okay, in this video, I want to explore what subnetting is about. Okay, and before we continue, I just want to start by uh, look giving you some tools which I'm going to use in this video. I'm going to use LibreOffice Calculator or LibreOffice Calc. Okay, the main objective of using LibreOffice Calc is to use the decimal and binary converter. You can download LibreOffice Calc with the LibreOffice suite. It is an alternative to Microsoft Word. Okay, so this is what we are going to use. The required software. The main functions we use in LibreOffice Calc, which is like Excel, is called binary to decimal. Okay, which converts a binary number to a decimal number, or decimal to binary, which converts a decimal number to a binary number. Decimal numbers are the normal numbers that we are used to. Why is it called decimal? Is because there are 10 numbers. For deci means 10. So you go from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is 10 numbers. For binary numbers, there are only zeros and ones. So there are two numbers that you can use. That's why it's called binary number. So to help us with subnet masks, we'll need to understand binary and decimal notations and be able to quickly swap back and forth between them. So that's very important for us. Now, without further ado, let's also explore the sources. Okay, the sources I use over here. Well, there are some things I use from LibreOffice document foundation. Okay, this is the decimal to binary thing, and I've also looked on Quora just to clarify some of my own concepts as to what subnetting actually does. Okay, and what is the purpose of subnetting. You can go and read all this in your time, or you can just watch this video and I'll explain slowly what subnetting is for and what is this subnet mask thing over here for. So without further ado, let's begin. So this is 247. Okay. Where did we find subnet masks? So if you have followed the series, I've actually done a practical. I just called it I've done a practical where you'll be able to identify the IP address. In this case, 192.168.7236/22. This is the IP address and the subnet mask expressed in something called CIDR notation. So that's a name you gotta get used to. CIDR notation. It is an acronym for something bigger, but I'm not going to I'm not going to expand on that. Just take it for now that CIDR notation is like a shorthand notation for IP address and its subnet mask. So if you want the full subnet mask, you use ifconfig and you look for the same IP address, which is over here, 192.168.7236, and the net mask here is 255.255.252 and 0. Okay, so this is where you will normally encounter your subnet mask. Okay, you will be able to see it inside your ifconfig or ipconfig if you use Windows. I'm not sure what Mac does, but okay. I'm not sure what Mac does, but this is what Linux does. ifconfig or IPA, this will be able to give you subnet masks. Note that this is Manjaro. There's one big Manjaro right here. So that is the Linux distribution I'm using. Ubuntu, OpenSUSE will be slightly different. Okay, so I'm not going to cover all the Linux distributions. I'm just going to use whatever I have. Okay, so what's the story behind subnet masks? Why do we have this thing called subnets in the first place? Okay, so why subnets? Okay, so for that, let me paint you a picture. And the picture painting tool I'm using is GIMP. Again, I like to use GIMP. Pardon me? Yeah, I should have muted that. Huh. Yeah. So, okay, suppose we have a small network, right? We have a small network of computers. Okay, so let's say this is computer 1, computer 2, computer 3, computer 4. Okay, again, not very neatly drawn, but usually all you have to do to connect all of them is use this thing called a switch. Okay, so you just need to use a switch, and technically your job is done. You don't need anything bigger. Problem comes is when you need to connect not 4 but maybe 4,000 computers. Let's say we have 4,000 computers now. All right. Is there going to be a switch? Is there going to be an Ethernet switch that's going to accommodate? Right. Accommodate. Is the Ethernet switch going to accommodate 4,000 computers? Right. So you have 2,000 on this side, 2,000 on this side. Probably not going to happen. Likely, you don't want so many Ethernet cables going into one single switch. That's just not practical. What's more likely? Okay. Likely you will have maybe 3 to 5 computers, or maybe 10 computers here on one local network of some sort, which are connected to a switch. Okay, 10 computers are connected to a switch, and this switch is connected to one computer. Okay, so the switches and computers looks kind of the same. Okay, let's switch. Oh no. Switch. Alright. Okay, let me delete this. So this is a switch, which I will use this tool to try and move it. Oh, wrong tool. Never mind. Let me delete it again. Delete. Okay, this should be switch. Okay, so this switch will be connected to one computer. Maybe we'll use a circle this time. And this computer will be connected to maybe another switch. Okay, and this switch will maybe have another 10 computers here. You see where I'm going with this? So maybe you have this setup, and maybe you have several of these circle computers. Okay, so whenever I draw a circle, assume you have this computer actually connecting to a switch from several computers. So I'll just draw these small boxes to represent switches with maybe 10 computers each, and then so on and so forth. You see, this is starting to look more and more like a network. And this is I guess the more realistic way of how you connect 4,000 computers. You don't connect them all together. Okay? You don't connect them all together, but you connect them through, I guess, computers that talk to each other, I guess. So you see these computers here, which I'm highlighting now, they become very important, right? They become very important, right? So definitely, if every computer is going to talk to every other of these computers on this network. Okay, let me slow down on that. Okay, let's say you have one computer on this network, right? You have one computer on this network. How many computers must I so-called let it talk to? Okay, if you connect everything directly like that, it's going to have to connect to 3,999 computers. It's going to have a very, very long up table and about 3,000 plus IP addresses to sort through. and you want to send messages to each of these 4,000 computers. Okay, so if this computer is so-called pinging each of these 4,000 computers and it's trying to sort through its messages, it may have to send, let's say if it wants to update its UP table, right? The address resolution protocol table. If it broadcasts a message, it will be broadcasting to, not broadcast a message, it will be sending messages to each of these 3,999 computers, right? If it's trying to let's say ask, okay, I have a IP destination address of 192.168.77. okay, if I want to send a message, if I want to send a message from this computer here to 192.168.77, and then I want to ask what the MAC address of this is, right? So I can send it there. So what this computer will have to do is to keep sending messages out and out and out until you find the correct MAC address of this computer, or the wireless card or the Ethernet card at this IP address. Okay, so it's going to have to send many messages out to try and find where this 192.168.77 is, for example. It may not be a very accurate example, but if it has to send 3,999 messages out to every one of these computers to ask where are you, or what's your IP address, or what's your MAC address, right? So imagine if you have not just 10 computers here trying to talk, or not just one computer trying to talk to each of these other 4,000 computers, but now 10 computers are trying to talk to each of the other 4,000 computers roughly. And you can see that the traffic would be increasing a lot. And just imagine if every computer is trying to talk to each other simultaneously. Okay, do you really need that to happen? I mean, do you need that much traffic to flow through? Because if you have every computer talk to each and every other computer on this 4,000 computer network, you will have a lot of traffic here. Right? You have a lot of traffic flowing back and forth between, I guess, these nodes or something like that, which connect all the switches or something. Yeah, so you can see already with 4,000 computers, it's very hard. Imagine you have 4 million computers, 40 million computers, 400 million computers. And then after that, you can add cell phones or smartphones, smart devices to this whole mix. So you can add Wi-Fi, I guess, to this network. So it will be a disaster of traffic, right? You have a big disaster of traffic if you don't manage your traffic properly. So how do you manage the traffic properly? Okay, the principle is this. Okay, to manage traffic, okay, I guess you can say this: talk to other computers only when needed. All right. So this is a very commonsensical way of managing traffic. That's the underlying principle, of course, very common sense. So talk to other computers only when needed. If you don't need to talk to other computers, don't talk to the computers. How does this play out? Okay, so we come with the basic, we come with the baseline that not every computer needs to talk to each other all the time, right? So for example, if you are tethering off your smartphone, okay, your computer in the phone will need to talk to the computer in your laptop or your desktop. You need to communicate very frequently, right? Or if it's sharing something via Bluetooth, okay, you will need to talk to each other very regularly, or Wi-Fi, or AirDrop, okay? So I'm using these terms very loosely. Again, it's not supposed to be networking accurate, but it's just here to I'm just here to lay down some basic concepts, right? So the thing is, I guess computers which are closest together physically, they need to talk to each other the most. But computers far away, you don't need to talk to each other that often, right? How many messages does this laptop need to send to a computer in the North Pole or Antarctica, for example, right? You don't need to talk to that computer specifically. I mean, why would you need to? Unless you have some special reason or mission or whatever, I don't really know, right? You don't really need to talk to all the computers all the time. So, to deal with this, right? Delete. So, based on this principle, we can actually divide out this system into smaller networks. All right. So this is 4,000 computers. let's say I want to split it up into I split up this 4,000 computer network into these computers here. Maybe there are about 30, maybe, or 300 computers. 300 computers. All right. These 300 computers, they need to talk to each other very frequently for whatever reason. All right. Okay, but they need to talk to computers outside the network a lot less frequently. Okay. So maybe you don't really need this connection anymore. So the traffic, okay, the traffic, let's see, the traffic over here and over here, it should be reduced substantially. So once your traffic over here and here reduces substantially, computers can talk to other computers outside the network a lot faster, because there aren't so many so-called junk messages, right? There are not so many junk messages. So that's the purpose of excuse me. Yeah, what I've just done here for you is show you the process of splitting up a big network into smaller networks, and this is what subnetting is for. So what subnetting does, the main purpose of subnetting is to ensure that you minimize traffic. Okay, so that computers that are close together, all right, they need to talk to each other the most. You group them together into one sub network, and then only messages that are going out of the sub network needs to be going to this maybe node computer. This node computer, perhaps you may have a special name. We call it the router. Yeah. Okay, the router. So the router, what routers actually do is to help one network talk with another network. Okay. Okay, one network talk with another network, but of course there's a lot more nuanced things I have to go through in order to get to the nitty-gritty of what a router actually does. But in a very high level thing, maybe an introduction of this is, or of a router, is to help one network of computers talk to another network of computers, otherwise known as inter-network communication. That's why I guess that's how I like to think of it. Okay, it may not be correct. Okay, but that's why you call internet, right? You have networks talking to each other, usually through routers. Okay, but this is a very big picture thing. I haven't come down to the details yet, and I may not have all the details right, but by and large, this is the picture of why you want to subnet. All right, so yeah. Okay, I'm not going to split up this video into two parts. I'm just going to continue and make it a bit longer. Alright. Alright, so it's about 19 minutes in. I spent a lot of time showing why subnetting is important. So let's start to understand a subnet mask. Okay, and what it does. So let's say you have these 300 computers, right? Okay, you have these 300 computers here. You want to give it a name, right? This is a computer network, right? Or computer subnet. Okay, computer network, or otherwise known as, in our case, a subnet. Okay, you want to identify these 300 computers with a name. Okay, because uh, in the bigger scheme of things, you want to start naming uh, computers. Okay, you want to not just name the computer's IP address. You sort of want to so-called group this whole bunch of computers together and give it a common name, so that you will know, okay, if I yeah, you will know which so-called subnet that the computer is connected to. Okay, you need to give this computer subnet a name. Okay, so it's easy to identify for outside networks. For inside networks, not that important, but for computers outside the subnet, it will be quite useful for them to know, okay, this computer is in this network, so let me direct traffic to this router which is connected to this network. Okay, so so again, not every computer outside the network needs to know the IP address of every other computer over the internet, but you do need to at least know, yeah, the you do at least need to know where this computer subnet lives. Okay, let's say this computer is trying to send a message to this computer, right? So this computer A wants to send a message to computer B, right? Yeah. So computer A will have the IP address of computer B, right? Yeah, computer A will have the IP address of computer B. So it will try to send a message through its router. Okay, the router will need to know, okay, where does computer B live? Okay, alright, where does computer B live? If you just give it an IP address here, alright, the router will have to basically ask all the computers all over the world, is this your IP address? Is this your IP address? Is this your IP address? Not a good way of doing things. But okay, if you don't just have your IP address, if you have the network address, right? If you have the network address of the subnet which this computer belongs to, it will make your search a lot easier. So instead of asking every single computer on the internet, is this your IP address? All right, you only need to if you yeah the way to avoid asking every single computer on the internet, is this your IP address? Like, is this 192.168.7.90, right? Instead of asking every computer over this network, is this your IP address? Alright, if you have 4,000 computers or 4 million computers, you want to ask this question? Maybe not the best idea. The way to narrow down your search is to provide the network ID. Okay, if you have a network ID, you will know that this IP address belongs to this computer network. Okay, it will belong to this computer network or computer subnet. Then the router here will know, hey, let me just forward the traffic to this router if I know what the ID is. And then let you take care of it from there, right? So normally you will not just have the IP address, you have the network address as well. You need to know the network address. So the network IP address, in fact. So this network IP address will represent so-called this network ID, identifying number. Okay, and if a computer is shown to be part of this network, okay, all the traffic can be forwarded to the router connected to this subnet. Okay. Okay, This will help you to narrow down your search, and again, the idea is to minimize traffic. Don't talk to computers if you don't need to talk to them. So that's why we have all these layers of complexity. We have subnets, we have network addresses. Okay, so I've not quite gone to subnet masks yet. Okay, yeah, I've not come to subnet masks yet, but I have covered sort of the basic knowledge that you need to get there. Okay, so this is subnet mask part 2. Alright, so yeah, so again, all the last 25 minutes of this video is just to give you a broad overview. I'll not be using the correct terms. I'll just be giving you rough ideas of, I guess, how I understand the networking process and why you have certain things. Okay, so yeah. Anyway, so the subnet, okay. Yeah, the subnet mask comes in here, alright? So you usually have two sets of data you will need to so-called narrow down your search. You need your final IP address, of course, but of course to make the search faster, you probably need your network address as well. Okay, so that your router will know where to direct your traffic without asking every single corner of the internet, is this your IP address? Are you computer B? Right? So where is this network address found? Okay, the network address or the network IP address, you can actually get it by combining the IP address here with something called the subnet mask. Okay, so the simple formula is IP address plus subnet mask equals network address or network IP address, right? Okay, so again, I wish the actual thing was this simple. It's not exactly this simple. Let me show you the more correct way. Okay, IP address, and you use the AND operator, and subnet mask equals to network IP address. Okay, so we use the AND operator, and you're like, hey, what AND operator? What are you talking about? Okay, so let's go back to our IP address here. So you see the IP address is here, and this is the subnet mask. Okay, and of course this is our subnet mask in CIDR notation, which is the shorthand version, which I'll not be going through just yet. Okay, but one thing I need you to know. One thing I need you to know is that, first thing first, all these numbers in the IP version 4, IP address version 4 kind of notation, all of these actually represent binary numbers. Likewise, these 4 numbers string together, 255, 255, 2520, all of these actually represent what do you call that? Binary numbers. Okay, so these numbers here, 192, this is actually part of an 8-bit binary number. Okay, or 8-bit, because there are 8 ones or zeros, so they are called 8 bits. Okay, so the minimum number of 8 bits is actually 0, and the maximum binary number of 8 bits is actually 255. So let's see. Let's go to the calculator here. Okay, I'll redo this for you. So usually we use the binary to decimal notation. So if you have a binary number here, we want to convert it to a decimal number. So we call bind to decimal, bind to DEC, and you just have this. Now it's 0, and if you want to convert back decimal to binary, oopsie, equals decimal to binary of this. Okay, so let's say you have a decimal number, you have 0, of course, then the binary number is 0. You have 255, and then you'll see the binary number is actually 8 ones. 1, 2, 3, 4, 5, 6, 7, 8. Of course, if I put 0, the binary number will be 0, but that's actually represented by 8 zeros in a row. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and that will just, of course, equals to 0. Yeah, it's not very interesting. Right? So for example, the number 7, let's put the number 7 here. The 7 is represented by 111. Okay, 7 is represented by 111. And if it's a 8-bit number, you just fill the first 5 digits with 0. And then 1, 1, 1. Okay, and this is how you represent 7 in an 8-bit number. Okay, you have the first 3, you have the numbers which are filled up towards the right. Everything else to the left is filled with zeros. So that's how you represent numbers in a 8-bit binary format. Okay, so okay, so let's take a look back at your subnet mask here. Yeah, why are we doing this? Because we are using the all of this this formula only makes sense in binary numbers. Okay, this formula only makes sense in binary numbers. So an IP address and your subnet mask becomes your network IP address. Okay, so if you want to find the network IP address, you need to use this, convert to binary numbers, use this, convert to binary numbers, and then you perform an AND operation on them, and then you will find your network IP address. So let's just do a simple exercise. We'll do it. Yeah. So let's do the IP address first. So let's do 192 and 168. Okay. So the number is here, 192. So that is 11 followed by 6 zeros. Okay, 1, 1. So this is 192, right? 192. 0, 0, 0, 0, 0, 0. Okay. Next number is 168. 168. 168 is here. Okay, 10, 10, 10, 0, 0, 1, 0, 1, 0, 1, 0, and 2 zeros. Okay, what's the next number? Next number is 7. So we just did 7 just now. I'm not going to do it again. 7 is 5 zeros followed by 3 ones. 1, 2, 3, 4, 5. 1, 1, 1. And what's the last one? Last number here is 236. So 236. Okay, let me zoom out a bit. Oopsie, 236. 236 is here. 236. Okay, it's 110 1100. Okay, that's a fair bit. 1 1. How many ones and zeros? I'm confused. 3 ones and 1 0. 3 ones, 1 0. 2 ones and 2 zeros. Okay. Okay, so right. So next step. Okay, we need to. So we have the IP address. We've converted it to binary. So that's part 1. So part 2 is what? Part 2 is the subnet mask. So what's the subnet mask here? Okay, 255, 255, 252, and 0. Okay, 255, 255, 252, and 0. 255 is the biggest number for your 8 bits, so it's a string of ones. So I'm going to, let me put it here. Okay, so 255 you don't really need to think about it, because once you do this a few times, you kind of know that this is the biggest number for your 8 bits, right? So your biggest number is actually equals 2 to the power of 8. I've changed to Chinese keyboard for some reason. 2 to the power of 8 minus 1, and that's equals to 255, because the first number is not 1, it is 0. So 255 and 255 is very easy. Okay, the not so easy one is 252. Okay, so it's the same except the last two numbers are 0. Okay, 252. And the last number of the subnet mask here is what? Where's the subnet mask? Yeah, it's 0. Okay, it's 0. Okay, and that naturally will just be a string of zeros. Alright. And okay, so now we've converted everything into binary format. What's the next step? Okay, we want to find our network IP address. Okay, and remember I said we have to use the AND operator. And what's the AND operator? It means, okay, if this is true, which is 1 is true, 0 is false. If this is true and this is true, the AND operator here will be true. If this is false and this is true, the resulting number is a 0. Okay, so if you look at these two statements or these two numbers, if you have a 1 or 0, the result, if you use an AND gate or AND operator, it will be a 0. Again, if you're not sure, it's a good thing that this LibreOffice calculator has an AND operator built in. So you can just use the AND operator here. Okay, and then it will just register true. And then you can just paste it here like that. Now, of course, it won't be nice ones and zeros, but it basically gives you the same idea. It's the correct idea. Okay, and if you want to convert this to a 1 or 0, you can use an if test. So if true, then 1, else is a 0. Okay, so I use the if operator here. Okay, I hope you know this what this is doing. Okay, let me explain in case you don't. So I use the if operator, and there are three things you need to fill in. One is a test value. That means it needs to have a true or false value put in. If it's a true value, then you will have this thing called the then value. So because usually we say if something, then something, right? So if it's true, then this cell should be displaying something. So let's say if this is true, you can type the word apple, otherwise orange. Okay. Oopsie. If this is true, type in the word apple, otherwise type in the word orange. I need to put this, yeah, so it will show the string. If I do this as a false, then you'll become an orange. Okay, so that's what this does. So if this is true, you put 1. If this is false, you put 0. So that's what I do. Okay, and I'm going to copy and paste all through, and we will get the network address very quickly. Well, not that quickly. We'll get it in a binary format. Okay, so this is our network IP address in binary format. So now we have to convert all these numbers back into decimal form. So okay, this one here is a binary number 11000000. Okay, this is exactly the same as here, so we don't really need to calculate. This thing is actually just 192. Okay, again, since we have 255 here, it means that all of these are ones. That means the number here will be the same as the number over here. So we don't need to calculate. We know that this binary number here is the same as this binary number here. Therefore, the decimal number, when you convert it back, it will be exactly the same. Alright, so whenever you see 255, you know your job's very easy. You don't really need to do anything, because 255 converts to a string of ones, and when you use the AND operator, okay, you'll find that all these numbers are the same over here. Okay, Now this one's a little bit more tricky. You have sorry, this one's a little bit more tricky. You have a string of zeros and ones here. Okay. Yeah, you have a string of zeros and ones here, and 252 should have two zeros at the back. So your resulting IP address is this 000000100. Okay, you can just ignore the first 5 because that doesn't really matter. You can just put 100 here, and then the decimal number is 4. Okay, you can put 4. Now what's the last one? The last one just has all zeros, and again your life is very easy. So if you ever come across a subnet mask with 255 or 0, you can sort of just throw away that part of the calculation. So what's your network IP address? You got a 0 here, got a 4 here, 168 and 192. Okay, so 192.168.40. This is your network IP address. Voila. Okay, so showing you how to calculate that. Alright, so that's 40 minutes in. Pardon it's so long. So last part, I did say that last part I did say that that you can convert between this CIDR notation, the shorthand form and the longhand form very easily. How do you do that? Again, the answer is through binary. Okay, the answer is through binary, and with binary it's easier to see. Okay, so if you have this number /22, okay, /22, what does it mean? It means that the first 22 digits of the subnet mask are 1. Okay, so let's count the number of ones here. You have 8, 16, 17, 18, 19, 21, 22. Is it? Okay, let me check again. /22, okay, 17, 18, 19, 21, 22. Did I miscalculate or something? Okay. Okay. Oh, no need to count A. Actually, the easiest is just to do a sum. Okay, and that will count all the number ones I have here. Oh yeah, 22s. So yeah, 8, 16. Okay, 16 plus 6 ones over here. So 16 plus 6 is 22. Yeah. So that means the first 22 numbers of these are ones. The rest are zeros. So that's why you have the number 22. Okay. So usually subnet masks you will be a string of ones followed by a string of zeros. This is usually what subnet masks are, and you can see why they are so called masks now, because when it's a 1, you sort of let all the numbers fall through. When it's a 0, everything else turns to a 0. So this part actually so-called blocks the numbers, blocks the binary numbers, and everything just becomes a 0. But everything here is sort of goes through, right? Okay, so this is what it means when you see the number 22. It means there are 22 ones in this subnet mask. So if you expand this out, you have to type 22 ones out individually. Okay, then you convert them into binary numbers. Okay, so this is binary numbers. There are 22 ones here, followed by a string of zeros. Then you can convert them back into decimal numbers. Okay. So likewise, again, if you want to convert this longhand form of writing your subnet mask, you have to convert all of these into binary numbers and count the number of ones before your first zero. Okay, because usually it's a string of ones followed by a string of zeros. There's no intermittent 1 and 0 usually. Alright, so that's how you usually that's how you do your conversion of subnet masks back and forth. Alright, so that's all. Hope you enjoyed this video and you learned something useful about subnet masks. Thank you.